Welcome back to the third video for our series in CAD. We're going to continue with sketches, and I wanted to touch on a few things that I didn't get to in the last video, mostly concerning constraints. So in an instance where you have constraints, and let's say you don't want them anymore, right now these two are concentric just in the way that I sketched them. If you click on the center, you have coincident, which is the center of the circle is coincident with the origin, and then you also have concentricity between the two circles. So if you click on the point, or whatever it might be, maybe the line or a radii, you'll see where you'll see the constraint that's listed there. And if you go ahead and click on it, you can just delete it by tapping the delete key, and that goes away. And now you can pull your circle out, and then the coincident one should still be here, so you can pull that off. So just wanted to show that, and that works if lines are parallel. Just draw two quick lines here and show how that works. So if you make these parallel, it's right there, and you can go ahead and click the delete key, and they're no longer parallel. So that's just how that would work. Now, something that is going to be touched on a little more when we get to drawings is going to be over dimensioning. It's more pertinent there because drawings are an agreement between an engineer or a designer and the manufacturer. Part dimensions are mostly just internal, so customers or anybody else isn't really going to see them, but it's still important to know. So in a lot of instances, you'll get parts that fit together. So let's say there's something like this type of feature, or maybe two parts interact and something slides in here, and we'll get to the point where we're discussing tolerances in another video. That's a whole separate discussion, but there are a certain number of dimensions that will parametrically define and a sketch. So if you have 40 there, and let's say we want this gap to be 80, and then we want this side to be 40 as well, and I would typically do this in a different fashion where I'd set this equal to this, and you'd have symmetry across an axis or whatever that might be. You also cannot, some people might want to go ahead and say that, okay, well, this whole thing should be 160 millimeters, but you'll get something where it's an over-constrained sketch. And that means that your CAD package doesn't know which dimension or which dimensions are the important ones, because right now they all work. But let's say, you know, this was 45 and you have 160 down here, then it doesn't know which one you want to be true. So what you can do is you can make this driven, and what that means is it's in parentheses, so it's a reference. So if I update this to 90, that changes to 170. So just understand that there are certain dimensions that will sufficiently define a sketch, and anything more than that will be considered over-defined. And it's very tough to cover all aspects of this because every sketch is going to be completely different. But and in a lot of cases, sketches may be complex, and you get to the point where you're dimensioning things, and you might just get an error, and it's no big deal. Just make sure you're dimensioning the important features. So typically in something like this, if parts are fitting together, the 80 might be important, and depending on what the geometry is, you could either have a dimension on the outer edges here, depending on how it interfaces with other parts. So you'd want to dimension based on what's important for your specific case. And while we're talking about dimensions and having things defined properly, we're going to go ahead and just make this coincident here. We'll just arbitrarily place some dimensions. So we're going to call this 100. We're going to call this 100, and we'll do 160, a nice even number. We'll do 40 here, and this is not the most efficient way. Oop, I just did what we shouldn't do. Was not paying attention. So come here, just do 50. We want these two to be collinear, so in line with one another. And notice how notice how all the lines here are white. In my specific settings, that means it's fully defined. Whereas if I deleted this, notice how it goes to light blue, this line here. That means that I can take the edge and I can drag it. It means that not everything is fully defined and there are still degrees of freedom allowed in the sketch. And you typically don't want that if someone doesn't know what they're doing and they open this and they drag a part of the sketch. It can completely change the part and no one would be the wiser. It's also good for revisions. So if you make a part and it doesn't fit and it's not dimensioned properly, when you go ahead and update the sketch and the drawing and the part, you may or may not know where it was before. Obviously if you have a drawing you will, but if it's just the part and you're trying to prototype, you wouldn't know what that was beforehand. So always super important to have everything fully defined. Now let's say, just for whatever reason, you have this sketch and you want to take and make this. There's a lot of different ways to do this. Might not be the best way, but just for instance, you want this sort of have a triangular feature there. You do have different features where you can offset and trim. We're going to discuss some of these. So I use this quite a bit, and this is where you'd want to click on the line. So let's just say this and this here. So there's a warning here that'll pop up saying that constraints may or may not be removed based on the lines that you cut, but basically it just takes away whatever feature you select. So in that case, and we'll do this again on this side, if I want this section removed, when I go ahead and click on the trim feature, notice how it goes purple, and that means it's getting rid of that part of the line. You can do that with all sorts of sketch entities. If you have sort of overlapping geometries, a lot of times when things get very complex, I'll design circles or different radii and let everything intersect, and when I have everything fully defined exactly the way that I want, then I'll go ahead and trim them. And it's just it's an easy way to get complex geometry in a very quick manner. So I'll actually show something I did earlier today. I was trying to create a path that a part would be bent to, and I'm sure there are many different ways for this to be done. I'm going to sketch this quickly because we've covered all of this and I just want to get straight to the point. So call this 100. We'll call this 100 as well. Nice clean round numbers. Call this 75. So I have this defined. Oh, I don't have this. Now it's fully defined. So I wanted this path, and I'd go ahead and create a sweep, which is a type of extrusion that we'll get to in a later video. In the meantime now, I just wanted to get rid of this part of the circle. So I just go ahead and do the trim, and it gets rid of that for me. So very simple, especially when you're doing things like that. And then in that same manner, there are other ways to offset or modify sketches pretty easily. So let's say I had a rectangle, or whatever feature it is, and I've dimensioned it to be oh, I meant to put 120 there. 70 is fine. And let's say the part is basically just a rectangle within a rectangle. So I can go ahead and just click the offset, and I click the sketch, and this is the distance that they're separated. So let's say I want it 5 millimeters, and I want to go ahead and flip this so it's on the inside. When I select OK, now the distance between this guy, or this line, and this line is 5, and it's kind of done that all around the perimeter. You can do that with all shapes, all sorts of complex geometry, as long as you have a complete continuous path of lines and radii. whatever other feature is sketched, and you can offset it by a certain amount, which is nice when you're trying to get parts that fit together very closely, or you have very organic parts. I've been doing that a lot with gasket design, so it's very useful instead of going ahead and sketching another rectangle or sketching whatever geometry is in there. It's just very simple. Now, while we're here, we can touch on probably what's going to be the last part to this before we start getting into making 3D shapes, is the fillet. This is rarely used in sketches. Fillets are usually a feature used once the part is in 3D. There are a couple instances where maybe you want to use this. If you do, every CAD package is different. Some you can select the point, some you select the 2 lines. I think you have the option of doing either here. So let's say we wanted to make this a rounded corner, which is what a fillet is. You're going to go ahead and click the point, and you can go ahead and put the radius as soon as it thinks. So now let's put a radius in here of 3. And I believe I use SolidWorks on a daily basis and use Fusion a little less so, but I believe you can also select the 2 lines and it does the same as well. So make that 6, and now you've got radii in the corners. So those are called fillets. Typically you use them at the feature level. With that complete though, I think we've covered everything in terms of sketches. So we're going to move on to revolves, extrusions, sweeps, some more complex 3D modeling features now, which are going to be useful, and that's when we're going to start turning sketches into parts, and it'll be a little more interesting, I think. So thank you guys for watching again.